Hello everyone, thank you all for being here. I'm very excited to do this because we've been working on this project for a few months now. Today we are unveiling a new Aura open source project and we think you might like it. So this project is being released under the Aura open source organization and it is sponsored by Insum. It's a tool that we hope you will want to use on your daily workflow. My name is Vincent. I've been working with Apex for over 6 years at Insum Solutions. You might know me from Twitter, GitHub, or my blog, where I've contributed to several open source projects. You can ping me on any of those mediums. I'm usually pretty fast to answer. Also, if you want to contribute to one of my open source projects, know that I'm very open to that as well. Any feedback or pull request is welcome, as it'll help the ever-growing Apex community. As you would have suspected, today we're going to talk about frontend. But before we do so, let's make sure everybody understands the differences between frontend and backend. Everyone has seen the iceberg analogy before. We know that the ice above the water represents the frontend stack. It's what users see and interact with. So CSS, HTML, JavaScript, these are the main frontend development technology. Underwater represents the backend stack. So we live in an Oracle world, right? That means database design, SQL, PL/SQL, and even more. Some of you are even considered full stack developers. That's when you're as comfortable on the front end that in the back end. Lately, we've seen some pretty crazy Node.js going along with Apex. And it basically fills the gap between the two stacks, as it allows to code seamlessly between the two stacks. And just look at the biggest Apex conferences. Count the number of sessions that talks about Node.js. It's astonishing. And that's way bigger than just us Apex developers. The whole web development community is thriving, and it's actually a fun time to be a developer. But getting back to the iceberg analogy, I believe it's even truer for Apex developers. The reason is we've been fed with incredibly rich themes for years, making it super easy to create visually pleasing applications. To be honest, you don't need to have any front-end knowledge at all to build an Apex application. And I know I'm exaggerating. There are some very talented front-end developers out there. But let's move on. Since front-end development basically comes down to HTML, CSS, and JavaScript, it's extremely important to understand the way static files are handled through an Apex application in its current state. As you might know, there are a lot of places you can put CSS and JavaScript. Whether it's inline code or as a reference to an external file, this kind of widespread use of front-end code can eventually lead to maintenance issues. So here's a table highlighting some of the possible locations you can put CSS and JavaScript in. You can choose from the application level, the theme level, page properties level, page 0, and basically anywhere. As soon as you open up a style tag or a script tag, you can put any CSS or JavaScript anywhere throughout your whole application. And you know how easy it is to override a CSS property with the important clause, right? Imagine that being in 5 different places. Now imagine that having to modify that a year later. From my experience, I found that being with junior developers, they can have a hard time understanding the differences between those placeholders. When building the Apex Frontend Boost project, we've decided to streamline the use of CSS and JavaScript. To put it simply, there shouldn't be any inline CSS or JavaScript anywhere. We encourage you to put every bit of code in static files. So let's say you start a new project. Let's say your manager doesn't want you to cut any corners. So you'll take everything very slowly. And you'll think about how you build these static files, right? It needs to be maintainable, they say. So with that in mind, you start coding meticulously. And you write perfectly balanced CSS, state-of-the-art JavaScript, and you're in good shape. You design some very well-crafted HTML templates, and that's it. You're done. What a great theme. You're very proud of yourself. and that is version 1.0. And time flies, a year goes by, your client asks you to start developing again, and you have to do some really, really simple changes. So you start searching, where did I hard code my background color again? And you do an application-wide search, or, maybe it's in a static file. I can't remember. And maybe you find it, maybe you don't. But for some reason, your background color doesn't work. CSS specificity is playing tricks on you. Everyone has overridden the CSS rule by adding a new one at the bottom of the file. Oh, right, and on top of that, there's obviously no documentation at all. So happy version 2.0. And it's true. It's hard. CSS and JavaScript are hard. It's hard to learn, it's hard to maintain, to organize, and to keep clean. And the more you change the original code base, the worse it'll get. And the only way to get around that is to have a perfectly well-structured code base that is consistent across the board. So today we are introducing Apex Frontend Boost. It makes coding faster, easier, and prettier. This tool helps you work with web files more efficiently within an Apex application. Apex Frontend Boost is a personal local web server that hosts and distributes your file to your Apex application. So without any further delay, here's what it looks like in a demo. So let's turn that off for a moment. And I'll just go to my Apex application. This is the most standard login page from a universal theme app, and the only difference is these two files, the first one being app.min.js and the second one is app.min.css. Both are pointing to the app image substitution string from the shared components. So as you can see, nothing fancy here. I'll just put that on the side and open up my text editor. First file is demo1 CSS. I've got some things going, but I'll just put it in comments for now. JavaScript, same thing, everything is in comment. All right. So what I'm going to do is launch Apex Frontend Boost. I'll launch the Windows shortcut now, which opens a command line, and I'll just put the project name. In this case, it's demo. And there it is, Apex Frontend Boost is launching. It's launching a bunch of packages, and automatically my browser opened up a new tab with the application running. So I'll get my text editor again, go to the demo CSS file, and try to take that without comments. And as soon as I press save, you're going to notice that this page is being refreshed. So I save and boom, the CSS was injected instantaneously and I didn't have to refresh anything, it was just injected. And same thing goes for any JavaScript modification, except that instead of injecting the code, it needs to refresh the page. So I'll take that piece of code out of comments and save again. My page was refreshed, and there I have the Hello World alert. One of the most powerful features of Apex Frontend Boost is being able to modularize your files. So instead of having just one huge CSS file in here, you could have as many as you want. So let's try to duplicate demo1 into demo2. And let's make the most basic thing. I'll just change all inputs, to have a fixed width of 50 pixels. And I save, and there it is. All inputs are 50 pixels. So I created two different CSS files, right? But I didn't modify the template or the page properties in Apex. It's still pointing to what it was before, meaning this file. So basically what Apex Frontend Boost did is compile everything that you had in the source folder of Atom, and it pushed it to the browser. There's many features available in Apex Frontend Boost, and I'll go in each individual one later on in the presentation, but that gives a good overview of what we can accomplish with static files without having to actually upload the file to the shared components again and over again. Also, one of the nice things to note here is that all modifications you do with Apex Frontend Boost running applies only to you. So the other developers that would be on this page at this very moment would not see that until you actually publish the changes in the shared components. So that being said, I will return to the presentation and continue on. Okay, so here's what we're going to cover today. First, we'll show how to install Frontend Boost, and then we'll show how to configure some of your projects. After that, you'll want to tweak your Apex apps so they communicate well with Frontend Boost, and then we'll show how easy it is to run the whole thing. Then, when you grasp everything that's going on, we'll deep dive into the available features of Frontend Boost, and trust me, there are a lot. And then, at the end, it'll be your turn for questions. The installation process. And don't worry, you're only going to have to do this once. So let's see what we need before we get started. Number one, Oracle Apex 5 Plus. So hopefully everyone agrees on this one. We decided to officially support Apex 5 and up, but there's no real valid reason why it wouldn't work on earlier version like 4. Second one, Node.js 4 Plus. Node.js is the architecture on which Apex Frontend Boost is based upon. Specifically, we will be using a tool called Gulp that will be watching your local files and executing the appropriate packages. FYI, if Node.js scares you, rest assured, you don't need any Node.js knowledge to use Frontend Boost. We will be providing a nice interface that hides all the complexity from Node.js related. And the third and last one, which is optional, Git, is it's optional because you can actually always download the project of GitHub directly. And until we publish the project to npm, using Git will be the fastest way to clone the project and get started. The command line. So, well, let's install this, shall we? First, we are going to have to clone this project locally. So this is where we're going to use git clone with the URL of the project that comes from GitHub. Once that's done, let's cd into the project folder. And the last thing we need to do is npm install. So that's going to take about, depending on your machine, it could take between 1 and 2 minutes to install. The last command, npm install, actually tells Node to install all the dependencies associated to Apex Frontend Boost. So now that we're done installing, let's configure a project or two. So Apex Frontend Boost, upon installation, generates a dummy config file like this one. It's up to you to configure your projects appropriately. So what I mean by project is actual Apex applications. In this case, we have two. The first one is invalid, but shows the correct structure. The second one on the bottom is completely valid with a correct URL, source path, and this path that actually points to my local machine. So this project is one of my project on apexoracle.com. So we need to specify the app URL right here, right below the project name that you can define yourself. And then you have to follow this structure, which is app URL, source folder, and this folder. So everything in here will be configured to each one of your projects. So now that you've configured your projects properly, we'll need to tweak your Apex applications a little so it can communicate with Apex Frontend Boost. And there are two ways to do so, but today I'm only going to show the simplest one. I invite you to read on both options on the official Apex Frontend Boost GitHub page, where you'll find detailed step-by-step information on how to achieve both. The first thing we want to do is build options. And for obvious reasons, Apex Frontend Boost isn't meant to run in production. So it's the development environment only. So in order to achieve that, we're going to create a build option called dev only. So this build option will have the status set to include, because it is going to be included on your actual development environment. But notice on the bottom, the last parameter is default on export exclude. So anytime you take your development application up for testing or directly in production, this build option will be turned off or excluded, which means any component that has been tagged to this build option will be excluded as well. Application process. And on a side note, since Apex 5.0, App Images is a repository available in the shared components, which allows to bundle static files as part of an application export. We encourage to use App Image as it makes the migration much easier than it was before. That being said, you will need an application process that we're going to show now that overrides the value of app images, the substitution string I mean. And that's in order to map your local files to the app image substitution string instead. All of that will be made possible thanks to a simple cookie trick that understands that Apex Frontend Boost is running and reroutes app images to localhost. So as I said, I will be using this application process to overwrite app image, and it is possible by a simple cookie. So just some really simple things to note. The production environment uses the app image as a default because of the build option that we created earlier. It will allow us to use Apex Frontend Boost only in the development environment. And the development environment will use localhost instead of app images. And here's the application process details. First parameter, sequence, we'll set it to -999 to make sure this is the first thing that happens. The process point is onload before header, also to make sure that it is executed before the static files are even loaded on the page. The name doesn't actually matter, but we might as well put something representative like OOS Apex Frontend Boost config. For all of you skeptics, yes, this is occurring on every page load, we know, but remember that this is for the development environment only. Hence, we apply the build option previously defined. The impact will be minimal. And without going into much details for the code, as you can see, it is very simple. First, we're looking for a cookie named OOS Apex Frontend Boost app images, and if it exists, we overwrite app images. If not, we do nothing. As I mentioned earlier, any static files must be referenced with the app images substitution string, regardless of where it leads underneath the hood. So here are two common examples for your CSS and JavaScript files. So we start with the app image substitution string and followed by your file path, which is in this case js/app min.js and css/app min.js CSS. And remember that this can be done at either the application level, theme level, template level, and page properties level, and even more. So if you are really interested in seeing the different options available for making the Apex setup, read the docs on the official GitHub site. And we're almost there. So let's run the damn thing now, shall we? Apex Frontend Boost can be executed in 3 different ways. If you're a command line purist, from the Apex Frontend Boost root folder, you can execute the following command: npm start -- again project equals your project name. If you're on Windows, you can execute the simple shortcut, which allows you to enter only the project name and then hit enter. If you're on a Unix environment, you can execute this command and then once more time, enter the project name and hit enter. This is really up to you. There's absolutely no advantages or disadvantages of using one over the other, just personal preference. Okay, that's it. You're officially done with installation, configuration, and setup. Now learn how to use it wisely you must. Remember that we've specified the source and destination folder in the config.json file? Well, this is where it all makes sense. So first, you've got to respect that subfolder structure on the left. Frontend Boost will be looking for that exact folder structure except for the two first ones, SCSS and less. So these ones are optional to your build, but you can still include them if you want to. The four last are required for Frontend Boost to work as expected. So the magic happens as soon as you save any file in these folders. The code will be curated according to your configuration and compiled into the destination folder. Your Apex application points to the dist folder only, so this is the one that you see on the right at this moment. So we've pretty much covered all the basics, and you've seen roughly what it can do earlier in the demo. Now let's dig into the specific features that personalizes Apex Frontend Boost to your likings. Note that most of them will be opt-in, so you don't really need to include any of them if you want, and you could use and stick to the basic setup that we've shown from the beginning. Browsersync is pretty much the main reason why you'll use Apex Frontend Boost. Basically, it eliminates the need for refreshing the browser. So as soon as you have any code modification in your code editor, it gets automatic code injection in the browser. It makes responsive development much easier by synchronizing devices together. So if you have, say, a PC, a tablet, and a phone connected to the same environment, they would imitate each other's action. So anything like clicking or typing or scrolling would be the same on each device as long as you've got Apex Frontend Boost running. This is a config.json example. It is enabled by default, but you can also turn it off if you wish. You can specify a port, meaning that it allows you to run multiple instances of Apex Frontend Boost for multiple projects at the same time. There's also an option for notifications. So it triggers a non-obtrusive alert on the top right corner of your screen, indicating that any CSS or JavaScript has been refreshed. As for the responsive development, I'll quickly do a demo to show the power of responsive development across Apex Frontend Boost. So if I go again to here on my demo page, what I'll try to do is duplicating this one. Oh, thanks, hello world. And here. So if I type in Vincent on the right, it puts Vincent on the left as well. So everything is duplicated, imitated, name it, on each instances of your application under Apex Frontend Boost. So obviously on this demo I cannot show any mobile demo of this, but you can imagine how useful it would be having 3 different devices in front of you for responsive development. And that not only helps the developer, but also testers and the QA department, and so on and so forth. Minification. Frontend Boost generates a minified version of your CSS and JavaScript code. A minified version of code means that all the spaces have been stripped out from the code so that everything fits on a single line of code. In JavaScript, you also get variables renamed so that they also take less spaces. In the end, your file is much smaller, so you also get a better performance on the browser itself. Let's say you've coded app.js in the source folder, so upon saving, the dist folder will contain both app.js and appmin.js. Your Apex application should always use the min version in production for performance reasons. We enabled this feature by default, and we also decided that you can't disable it. The reason is there is no reason to use the unminified version on a system in production, so we might as well just include it all the time. So as an example, I can show you from our two CSS files from before. Demo1 and Demo2 are in fact compiled into the dist folder under CSS, and you would get app.css, which contains both of the files, and app.min.css that contains the same thing but on a single line of code. As I said before, your Apex application in production should always use this one for performance reasons. So in the previous example, we actually merged two concepts at once. And the second one was concatenating the files together. Doing so is good practice because it reduces the amount of HTTP requests to the server and therefore enhancing the performance. Also, having just one file to declare in the Apex templates makes coding easier. This feature is not enabled by default, so I actually had to do a little tweaking in the config.json file, but it's kind of easy to achieve by just declaring a file name under the JavaScript concat and CSS concat objects in the config.json file. So I'll skip this example for now because you've seen in the previous one the combination of concatenation and minification and the effect it has on your Apex application. Error warnings. Using a language such as PL SQL sure has its advantages because it's a compiled language, right? And you're being notified of a syntax error pretty much right away as soon as you compile. As most of you know, CSS and JavaScript aren't like that. They're interpreted languages, which means that you won't know what's wrong until you actually have the error in front of you. So to counter that, we've included code linters with Apex Frontend Boost, which means that as soon as you do a syntax error on your file, the command line interface will immediately tell you where and why you've made an error. So so that's what the interface would look like, but let me show you an example on our previously defined JavaScript file. Okay, so this is demo1.js, and on the left we've got Apex Frontend Boost. So let's say I forget to put the semicolon and I save. Well, first of all, my page got reloaded, but also I was notified directly that on line 2, column 26, I'm missing a semicolon. It seems pretty obvious because we're used to code in PL SQL and SQL, and you get all these tips, but you actually don't in JavaScript. So it's pretty useful to have it built in with your environment. So I'll just fix that for now. Thank you. Okay, source maps. I love this one. One of the drawbacks of working with minified files, is that it becomes impossible to debug. Have you seen a JavaScript errors that looks like this? It's literally a mess, right? So Apex Frontend Boost comes with built-in source map support. Source maps are a tool that is linking the final minified file, so this one, to the original source one. So instead of seeing this whole pile of code, you'll be able to trace your code back to the right place. We're enabling the source map by default because it just helps everybody. There's no drawbacks of having the source map on your application, so we might as well just include it. And it may not make sense for now, so I'll just do a quick demo again. I'll open my Apex app. Turn that back to normal. Okay, so remember I had a color change on demo1 CSS and a width on the inputs of demo2.css, right? If I open up the console and inspect what's actually going on underneath the hood, right here for this one. So you know that this page is actually loading app.css, which is the compiled version of everything. But with built-in source map, the browser is able to map the original demo1.css to your console inspector tool. And if I were to go in the input, I would see somewhere down the road that the input, which is set to 50 pixels, belongs in demo2. And just to prove it to you, in the header section right here, oh, I did miss it. Oh, here it is. So the app is calling app.min.css, but it can trace back the original source files when you inspect it. Okay, next up is CSS preprocessors. Today we won't get into the what, why, or how CSS preprocessors because there's just way too much to cover, and we could do a whole session on Sass or a whole session on less. But just know that they're awesome and you should try it sometime. So for now we support officially Sass and less, and both are disabled by default. So what you need to do to enable it is just add one of these two objects to your config.json file to enable either Sass or less. Obviously, you can't really enable both because it wouldn't really make sense to have two different CSS preprocessors on one single project. So let's see what it does if we enable Sass on the demo application. So first thing I'll do is rename the CSS folder to SCSS, and then inside of that I'll rename demo1 to SCSS and demo2 to SCSS. Now we're all set. We just need to change the config of our projects to add the SAS feature right here, and enabled is true. Okay, so I'll close Frontend Boost. I'll run it again off the Windows shortcut on the demo application. I'll put that on the bottom, Atom on top, and my browser was launched. So I see the same JavaScript, same CSS, the blue header alert. Just close it up, and if just close these files, sorry about that. And now if I look at demo 1 CSS, SCSS, and demo 2, what I could be doing instead of the hard-coded with is use variables. So now, instead of having to hard-code 50 pixels right here under the input selector, I can declare variables and use it pretty much anywhere in the code. So that's one of the many useful features that a CSS preprocessor offer. But if you want to know more about SAS or less, just visit their websites, and you will be able to use all of their features right here off your Apex project using Frontend Boost. Autoprefixer. Some CSS properties require complex knowledge of browser vendor prefixes. Have you ever wondered why some CSS has to be written like this? So you've got display WebKit, display WebKit Flex, MS Flexbox, display Flex. It's a mess, really. Apex Frontend Boost comes with Autoprefixer built in. So that means instead of writing all these 4 lines of code, you could be writing a simple line with display flex, which removes all the complexity from writing vendor prefixes in CSS. Let's do a quick demo on this one as well on the same application. So I'll go again on demo 2. And the input, I will just write display flex, and there it is. It's refreshed, and I'll show you what it looks like on the console right here. So there it is. I only wrote display flex, but my input that comes from demo2.scss, and yes, it can read SAS code in the browser itself. And as you can see, the source file was display flex, but on the element itself, you've got all the vendor prefixes. So you can actually forget about all the specific cases where this property applies to Firefox or Internet Explorer. It's all taken care of by Autoprefixer directly from Frontend Boost. The last and not the least, Theme Roller. Frontend Boost is highly compatible with Theme Roller, meaning that it can generate code so that your application has custom Theme Roller attributes. So can you see that picture on the right? This is not universal theme at all. It is completely custom Theme Roller attributes that has been made for this application only. So in a nutshell, Theme Roller reads a less file with predefined variables. Frontend Boost helps by creating these less files based on your code. This is what it would look like on the config.json file if you wanted to enable Theme Roller. By default, we are not doing that because we don't think every developer wants to configure theme roller differently. So we have it disabled by default. If you want to have it enabled, you need to specify a final name right here that would be mapped to your theme configuration in Apex from the shared components. But today I won't get into the details because it can become very, very complicated, and I'm actually doing a whole session on this at glog 16 and kscope 16. So if you're interested in knowing more about theme roller and front-end boost, please attend my session at glog 16 or kscope 16. So we've been through all the main features, and that was Apex Front-End Boost. Let's do a quick recap, alright? So first of all, what it does, it minifies code, meaning that any spaces and unnecessary spaces in your code will be shrunk down to a single line of code, making the file much smaller. It concatenates different files so that there's only one HTTP request that's made to the server on your app. It adds CSS and JavaScript source maps so you can easily trace back the code to your original file name. It deals with CSS preprocessors such as SAS and less. It automatically adds vendor prefixes so you don't have to worry about the different browser compatibility. It automatically adds theme roller configuration to your application and more. Also, Front-End Boost helps you cutting down on front-end development time. It enhances your application performance due to smaller file sizes. It lets you keep coding in your favorite code editor. It allows you to stop worrying about browser refresh as it does it for you automatically. And all the changes affects you and only you, so other developers at the same time on the same application won't see what you're doing on Front-End Boost. And last one, error notifications. You get any error notifications as soon as you save on the interface of Apex Front-End Boost. So remember, this is an open source project. Please provide feedback. Feel free to submit issues or pull requests, and this is how we'll make this product even better. Thanks to all for tuning in. We are proud to make this tool available today, and we hope it will be as useful to you as it was to us. On a side note, I'll be giving this session at glog 16 and kscope 16, so if you're interested in knowing more, please come see me. Okay, your turn now for questions.